Okay, so let's do one more hypergeometric. Okay, so the hyper. Okay, for geometric distribution, you can always refer to the document that I've shared. Okay, and for the others, you can try them on your own. Okay, just make use of all the functions, try and understand what's going on, and it should be fine. Okay, so hypergeometric distribution, you can see over here. Okay, it has so I have to check, what is this? Yeah. Okay, so you can imagine that this is an experiment. It has so the experiment consists of drawing balls from an urn. Okay, so you have an urn from which you are drawing balls. Okay, and the urn has only two types of balls: white balls and black balls. Okay, white balls and black balls. Okay, and suppose small m is the number of white balls in the urn, small n is the number of black balls in the urn. Okay, and suppose k is the sample size. Okay, the number of balls drawn from the urn. Okay, so of course you cannot draw more than m plus n balls. Okay, the reason is this is sampling without replacement. I mean, of course, if it would have been a sampling with replacement, you could have drawn as many number of balls as you please. Okay, but this is a sampling without replacement, so you cannot draw more than m plus n balls. K is the sample size here. Okay, so m, n, and k, are these parameters. Okay, so that is what you have to specify, how many you are drawing, and you are interested in number of white balls. Okay, you are interested in the distribution of number of white balls. Is that okay? Fine. So let's just quickly check. Let's do this particular problem for numbers that we know, and for which we know the answer, and then we can quickly verify that we are going to get this. Okay, so let's do this problem. Suppose you are drawing, so let me give you a problem. Okay, suppose you have 3 white balls, 4 black balls. Okay, fine. And suppose you draw a sample of size 2. Okay, what is the probability that you will draw 1 white ball? So x is number of white balls. So you're going to draw 2 balls one by one from this urn without replacement. So the question is, and x is basically how many white balls you end up drawing. Okay, so what is the probability that you will draw 1 white ball? What is it?
3 is the number of white balls.
3 is the number of white balls. 3 choose 1. Into 4 choose 1, because if you're drawing 2 balls, if one is white, the other one must be black, divided by 7 choose 2. Okay, so that should be the answer. Okay, and what is px0? Four choose 2 divided by 7 choose 2. And what is px2? Yeah, so it is 3 choose 2 divided by 7 choose 2. Okay, so what we'll do is we'll calculate these numbers. Okay, and we'll also use the dhyper function and verify the results. Is that okay? Fine. Okay, let's do this. Okay, so m is 3, n is 4. Okay, k is 2, right? That's the sample size. Okay. So d hyper 0:2, right? Because we can only draw up to 2 white balls, right? I mean, you can draw either 0 white ball, 1 white ball, or 2 white balls. Okay, of in which order? M and K, M N K. Okay, let's run this. Let's figure out what these values are. So you can just select, all of them together and then, run them together. So you can see these are the probabilities. Is that okay? Now we'll just quickly verify with them. Of course, we should get the same thing. Okay. So what is the probability that X is 1? Well, according to this, it's 0.5714. Okay. And if we actually calculate it from here, okay, we'll get 12 divided by 7 choose 2, choose 7 2. Okay, let's run this. And it is indeed the same. Okay, is this fine? Have you understood this? Okay, so this is how you can use hypergeometric function. Okay, so let me give you a problem. Okay, so of course not every problem is like the white ball, black ball, but there are a lot of problems that can be mapped into this particular problem and then solved in exactly this way. Okay, so this is not just for balls. Okay, it can also be done for any kind of problem where we are actually drawing sample without replacement. Okay, for with replacement, you know that you can use binomial. For without replacement, you can use hypergeometric. Okay, so now suppose I'm interested in drawing 5 cards randomly from a well shuffled deck of 52 cards. Okay, and I'm interested in the number of aces. Okay, so let me just write it. Okay, I want to draw 5 cards from a well shuffled deck of 52 cards. Okay, and I'm interested in number of aces. Yeah, but let's just do it using R. Okay. Okay, so draw 5 cards from a well shuffled deck of 52 cards, and I'm interested in the number of aces. So obviously, number of aces cannot be more than 4. Okay, and so basically, we are interested in the probabilities associated with 0 aces, 1 aces, 2 aces, 3 aces, and 4 aces. Okay, we want to find that quickly. Okay, so of course, we also know the formula. We can derive that formula. It's the same formula that we just did. You can also do it using that, but let's use a d hyper geom function. Okay, so this particular problem is exactly the same as that problem where you're drawing balls. Okay, so here white balls can be thought of as aces. Okay, and non-white balls or black balls can be thought of as non-aces. Okay, so how many aces are there in a deck? 4 aces. How many non-aces are there in the deck?
48.
48. How many you are drawing? How many cards you are drawing? 5. And you are interested in the probabilities associated with 0 ace, 1 ace, 2 ace, 3 ace, and 4 aces. So 0:4. Okay, and let's run this. That's the PMF. Okay, of course, if you're going to sum them, you should get 1. Okay, let's quickly check this, because these are the only 5 possibilities. Okay, and that's 1. Is that okay? Clear to everyone? Okay, so why don't you quickly plot the PMF? Just quickly plot the PMF of, so use the commands that we did for the binomial. Okay, just use ggplot function. You don't have to load it again, it's already loaded, so you don't have to use that library ggplot again. Okay, so now you can straight away use ggplot function. Let me know when you're done. I'll do this. You can always also do Google search. Of course, that's always an option. Of course, you can take help from R, okay, using the question mark, but sometimes it's actually faster if you just use the Google search for whatever you want, okay, and you'll find a lot of answers on Stack and elsewhere, which will help you in doing whatever task you want to perform. Okay, and secondly, of course, you can also use the forum. Okay, you can discuss with other participants. Okay, whatever you want. Okay. Okay, so let's quickly plot this. Okay, no problem. Okay, so you can just, again, as I've just said, that you can use the ggplot function. So what you can do is, you can, if you want, you can create the data frame first, okay, because that's going to go as an input. Okay, so the x values will be okay, data dot frame. Okay, x values will be 0:4. Okay, fine. Okay, and the probs is basically, these are the probs. Okay, and now it's the same thing. Okay, it's just copy paste if you wish, because I've just used the same variables. Yeah, I mean, it's always good to have a standard thing, because you don't want to keep changing it all the time. Okay, so so if you see, this is, I think this is all that you need. Okay, okay, so I'll just change this to hyper geometric. Okay, and this is what, MNK, right? So, or basically just write PMF of number of aces. That's better. Okay. Number of aces in 5 draws. Okay, let's run this. Okay, so this is it. Okay, that's a PMF. Is this clear? Okay. So and as expected, right? I mean, ace is anyways very unlikely. Okay, I mean, so probability of getting higher aces is lower. Is that fine? Okay. But if you, of course, if you draw more cards, then it's possible that probability of getting more aces, you know, will increase. Okay, like for example, if instead of drawing 52 cards, you draw 26 cards. So instead of drawing 5 cards, you draw 26 cards. So if you draw 26 cards, then the probability of getting 0 aces will be smaller. You can actually check this. Okay, let's draw a sample of size 26. Okay. Let's run this. Notice that, I mean, you just have to make one change. So try and write your code in such a way that you don't have to make changes at multiple places. Okay, so if you just make one change, you'll be able to get it. Okay, you can see that, so you just write k equal to 26 and let's run this, and you can see it's like this. Okay, so probability of getting 2 aces is now the highest. So 2 is the mode of the distribution. Earlier it was 0. Okay, now it is 2. Okay, mode is the most, yeah, so the one with the highest probability, the one with the highest PMF. Okay, fine. Is this fine? Okay. Okay. Okay, so do you want to generate some numbers from this? Do you want to try that out, or should I move on to continuous distributions? I mean, there are other functions. If you want, you can plot the CDF. Why don't you try plotting the CDF? CDF is always going to be a non-decreasing function, right? I mean, it's just because CDF is probability that x is less than or equal to x, and as x increases, the event is actually becoming bigger. So clearly, the chances of that event is going to also get bigger. Okay, so it's a non-decreasing function. So why don't you try and plot a CDF for this? And what change will you make? Where will you make that change so that you get the plot of the CDF, cumulative distribution function? So what should I put here? P hyper, absolutely. Okay, so instead of D hyper, use P hyper. That's it. Okay, that's it. That's the only change that you have to make. Okay, and now you will find that it's an increasing thing. Okay, can you see this? Okay, make sense? Have you understood this? Any questions? Okay.
Yes.
Okay.